And here's a brief repeat of the. Now for a different look at the band changing demonstration. At the bottom of the picture you can see the band buttons of the Alpha 87 indicating which band the amplifier goes to as it follows the transceiver. And at the top a Nye watt meter, I'm tripping the box here, the Nye watt meter with a peak and hold function that allows you to read what the peak power actually is, so you can tell how soon after a band change the power reaches full output. Hello, test 1 2 3 4. We're on 28 megahertz. Hello, test 1 2 3 4. This is 7 megahertz. 1 2 1 2 3 4 test. We're now on 20 meters. 1 2 1 2 3 4. 1 2 3 4. This is now on 15 meters. 15 meter sideband. And now we'll take a jump to 160 meters. Hello, 1 2 3 4. You can see again that the full maximum power output is achieved after the band change in a matter of less than 1 second in every case, even a jump all the way from 10 to 160 or vice versa. Now there are a few solid-state amplifiers on the market, of course, that are designed with special circuitry to follow from band to band transceivers of the same manufacturer. None of them is capable or rated for maximum legal power, 1.5 kilowatts, high duty cycle or any other duty cycle, and certainly none of them has the ability, what we might call reserve power, for peaks in excess of maximum legal power. The remarkable thing about the 87A is that it automatically performs the band switch tune-up function that I've just demonstrated again with any transceiver. If your HF transceiver will put out 50 watts on the ham bands between 1.8 and 10 meters, 1.8 megahertz and 28 megahertz, then it will work completely compatibly with the Alpha 87A, because the 87A, you see, doesn't require special circuitry to know what band your transceiver is on. It actually samples the incoming drive signal during the very first few milliseconds of a transmission, of every transmission. A digital counter in the 87A counts the incoming frequency, takes no more than 10 milliseconds, and then compares it with the frequency to which the amplifier is tuned, and if a change of frequency, change of tuning, or a complete band change is required, it's performed automatically within less than 1 second. During the time that the amplifier is actually band switching and retuning, the transceiver is bypassed to the antenna directly. So although you're down a few dB, 10, 15 dB from full power, even during that half second, you're still on the air, there's no interruption of the transmission. On CW, it's possible to take a band change, to accomplish a band change with just a single DIT at any speed. On sideband, just a click of the TR switch, push to talk or Vox ordinarily will change bands, or you can simply start transmitting. Let me just demonstrate that quickly on a few bands. In some cases I'll use just a single DIT. In other cases I'll send a string of DITs so you can follow what happens on the amplifier. Right now we're on 21 megs. Let's go to 28 megs, 1 DIT. Let's go to 7 megs, 1 DIT. Now to 20 meters, 14 megahertz. Okay. The 87A isn't afraid of continuous locked key operation, as you would expect from any alpha. Here I happen to have picked 10 megs. I'm using a dummy load, a Big Bird dummy load, so we're not on the air. Power is something in excess of 1500 watts, probably about 1600 watts. Continuous lock key. And just let it run for a while. You can see the band indicator there, 10 megahertz. And here you can see the, with a little better resolution, the steady state reading, key down of the Nye watt meter reading just to 1600 watts as indicated. Now, there's no particular reason why we need to stay on 10 megs, let's just switch to, say, the 18 meg band. Again, we have 1600 watts. You can adjust the drive a little. And leave it at 1600. And we could do this all day, but we don't have time. I might have said it at the beginning. An additional remarkable thing about this Alpha 87A is that it's no larger or only slightly larger than the typical deluxe transceiver and only slightly heavier, yet it has the same power ratings as the Alpha 77DX, the flagship of our amplifier line until a few years ago. It's rated at 1.5 kilowatts, brick on the key, continuous carrier all day long, has a substantial reserve of peak power capability, again equivalent to the Alpha 77DX's capability. Despite its very high power capability and very small size, modest weight, the Alpha 87A is very difficult to hurt. It's very difficult to damage it because there are a large number of protective functions, intelligent protective functions, provided through the microprocessor control circuitry. These include thorough protection of the 3CX800A7 power tubes against grid over dissipation, plate over current, over temperature, and so forth, as well as protection against internal arcs and a variety of possible failure modes. Let's take a few minutes now and I'll try to demonstrate how a number of these protective functions work. Now for these demonstrations, I'm using the transceiver with the highest output power rating of any on the market, the Yaesu FT1000D. Let's suppose, first of all, that you have been operating barefoot with a high-power transceiver like the 1000D or the IC781, Kenwood TS950, and you've had the transceiver power output control wide open, 200 watts, and it really does deliver that. You turn on your amplifier and you forget to turn the drive down. I have the transceiver set on CW, so I'll just squeeze the push-to-talk switch and we'll shoot 200 watts of drive into this 87. Well, you can see from the meter, you probably can't read it from there, but you can see the power output meter on the FT1000 is right up at 200 watts after the bypass. The Alpha, in just a matter of a fraction of a second, switched to standby. The standby light is on. The fault light is also on, and 3 lamps are blinking on the bank of segment buttons. Let's take a closer look at the 87. Now, if we'd remembered that the transceiver was set for wide open, 200 watts, we probably wouldn't have turned it on with the amplifier connected. So you assume you don't know what happened. These 5 lamps on the 5 segment buttons have binary values of 1, 2, 4, 8, and 16. If we add up the value of the lamps that are flashing, that gives us a fault code that I can, or you can then look up in the instruction manual, and it will tell you what happened. 1 plus 4 is 5, plus 8 is 13. Fault 13, I happen to know, but you could look it up on page 17 in the Alpha 87A instruction manual. Fault 13 is drive power in excess of 150 watts peak. What a surprise. Now what do we do about it? We turn off the exciter, of course, and all we have to do to reset this fault is toggle the operate standby switch just momentarily back to standby and then to operate, like that. And the fault is reset and we're ready to operate.